Okay, guys, let's go ahead and take a look at this warm-up. And I just need to turn that off really quick. Here we go. So I warned you that something weird kind of happens on this first one. So it says to solve these systems algebraically. Algebraically just means don't do it by drawing a graph, okay? So there's two main ways to solve a system, graphically on a graph or algebraically. And algebraically means without a graph, so that would leave you with either substitution or elimination, okay? Now, if you take a look at how this is set up, notice that the X's line up, the Y's line up, the equal signs line up, the numbers match up. So when that happens, when everything is lined up, you really should try to do elimination. It's going to be a lot easier, generally speaking, than substitution. But if you absolutely only love substitution and want to do it every single time, that's your call. I'm never going to say you have to do it a specific way, but when they are lined up like this, it really is designed to make elimination the more straightforward, easier way to do it. So that's what I'm going to do. And if you did it a different way, as long as you get the right answer, it doesn't matter. So elimination, you guys want to eliminate X or Y? Someone make a choice. X. Okay, so to eliminate X, notice here that this is -6, this is -2. I can turn this into a +6 so that it eliminates. To eliminate, you want to have the same number in front. So to eliminate X, we want to have these two be the same number, but one of them negative, one of them positive. So since this one's -6, I'm going to turn that into a +6 by multiplying by -3. Okay, so let's do it. Equation number 1 is going to turn into +6x minus 3y equals +15. So multiply by -3, -3, -3. This one we're just going to leave alone. You could say you're multiplying it by 1, but basically we're not doing anything to it. Okay, eliminate the x's. Just like we planned, they eliminate. Now let's take a look at our y's. What's -3y and +3y? 0. They also eliminated. That's the weird thing that I said was going to happen. But you do get 0. So it is important that you write 0. Because you eliminate here, you eliminate here. The left side, what's left is a 0. Yeah, nothing's left, but you need to write the 0 because when you add the 15 and the 16 and you get 31, I get two numbers here. 0 equals 31. Is 0 equal to 31? Is 0 ever going to be equal to 31? No. So if you solve the system, you will always end up with this, that 0 equals 31. This is never true. In fact, they are not equal. They're not equal, you know, they're not equal to each other. They're not equal. So what does this mean? It means that we can't solve this. There is no solution. Whoops. Trying to erase that. There we go. There is no solution. Okay. Does anybody have an idea what this would look like if we did graph it? If you have no solution, and remember that a solution is a point of intersection. So what would these lines look like if they were graphed? Anyone think about what that could be? We're going to talk about it a little bit more today anyway, but it starts with a P. Parallel. So what really is happening here is these happen to be parallel lines. Parallel lines never intersect, so there's going to be no solution. But this is how you can tell. You end up with two numbers, the variables eliminate, the two numbers that are left are not equal. So if you have two numbers that are left and they're not equal, there is no solution. because the lines are going to be parallel. Okay. Part B, we don't have that. Part B works out exactly like we expect it to work out, meaning that you get a solution. This one, though, I would do substitution. See how it says y equals right there? That means I can take this and substitute it up there for the y. So when you see an x equals or a y equals, substitution is going to be the more straightforward approach. Again, it doesn't mean you can't do elimination. If you love elimination that much, that you want to rewrite these so that the x's and the y's and the equal signs all line up, you can do that. However, with a y equals, I think it's easier just to go ahead and substitute. So I'm going to substitute 2x minus 3 where the y used to be. So right here, negative 3x plus 2, that's my y, or it used to be my y, equals negative 7, and now we can solve. So negative 3x, distribute. Okay, so we get that. Adding here, we get 1x, combining those. I can add 6 to both sides to move the 6 to the other side. So that leaves me with 1x, because negative 3 and 4x is 1x, equals, and then over here we get negative 1. So I now have my coordinate, my x coordinate for my point of intersection, and now I need to come back here and find y. You can use either equation, but the second one's a lot easier this time. So I'm going to use that. So y is equal to 2 times my x, and then subtract 3. 2 times negative 1 is negative 2. Subtract 3, we get y equals negative 5. So we do get a solution this time. Remember, a solution is a point of intersection. So when you're solving a system involving x's and y's, you want your answer to be the point of intersection. So we're always going to write our answer this way, with the one exception of a word problem. Because a word problem, we're not really finding a point of intersection here. It doesn't say what's the point of intersection. We are finding the cost of a fajita and the cost of a taco. So even though, yeah, graphically it would be a point of intersection, we just need to directly answer this question. So, world-renowned Wildcat Cafe, they have combinations of tacos and fajitas. And number one special, 2 tacos, 3 fajitas for $10.50. Number 2 special, 4 tacos, 2 fajitas for $11. What's the cost of each fajita and each taco? So we need to set up a couple of variables. So we're trying to find the cost of each fajita and each taco. So let's go ahead and say F, because fajita starts with F, equals the cost of a fajita. And then T would be the cost of a taco. Notice that when I define my variables, I am defining them exactly what they represent. So don't just say F is fajita, T is taco. What about the fajita are we finding? Sometimes it's how many, but in this case, it's the cost. We're not trying to figure out how many fajitas somebody bought. We know how many fajitas go into each special, but what we're trying to find is the cost. So read the question and make sure that you define your variables based on what it's asking. So we need the cost of a fajita and the cost of a taco. And then also keeping in mind that when you're finding cost, cost is dollars and cents. Negative numbers don't make any sense for cost, but decimals are fine. You can have a cost of $1.25. So dollars and cents are fine here. So we can expect maybe some decimal answers here. Okay, it says the number 1 special. I can get 2 tacos and 3 fajitas for a total price of $10.50. So I'm going to set up an equation for the number 1 special. 2 tacos and 3 fajitas for a total price of $10.50. Okay, combo 2 has 4 tacos, 2 fajitas for $11. So there's option number 2, the number 2 combo, 4 tacos plus 2 fajitas will cost $11.00. Okay, now again, here's my system. Substitution versus elimination. Lines up, the equals lines up, the numbers line up. This is going to be easier to do by elimination. Okay, I don't want to have to solve for t equals or f equals, especially since it looks like I would get fractions. I would much rather eliminate. So let's eliminate. I want to eliminate the tacos or the fajitas. Tacos. So tacos, I've got 4 tacos here. So I can eliminate if I multiply that one by -2, because this will give me -4 times tacos. I need 4 to eliminate with -4. So multiplying that by -2 will give me what I want. So I got -4 times t minus 6f equals, and then -2 times $10.50 is -$21. And then I have my 4t plus my 2f equals 11. And now we add these 2 equations together, and sure enough, my tacos have been eliminated. So I'm now just left with some fajitas, -4 of them. -6 plus 2 is -4 fajitas. -21 and 11 is -$10. Okay. So we're going to divide -10 by -4. Okay. I know it doesn't divide evenly, and we've said in the past that when things don't divide evenly, feel free to leave it as a fraction. This would be the exception to that, because what we're trying to figure out is the cost of a fajita. Nobody goes to a restaurant and gets prices in forms of fractions. Prices are always in decimal form, dollars and cents. So I really do want to take 10 and divide it by 4 and not leave it as a fraction, but realize that that is $2.50. Okay, so $2.50 is the price of a fajita. Now negative divided by negative is a positive, and that's what we want. We need a positive price. So I now know that the fajitas are $2.50. The tacos, I need to take one of these 2 equations here. Let's take this first one. Hold on one second. Let me pause. Back where we were here. So we got the fajitas. We need to figure out how much the tacos are. So 2t plus 3 times f, and each fajita is $2.50. This is just this top equation right here, equals $10.50. So 2t plus $2.50 times 3 is $7.50 equals $10.50. Subtract $7.50 from each side. That means 2 tacos for $3. Divide by 2. Each taco is $1.50. And feel free to do any of the calculations on a calculator. Any of the adding and dividing and all of that, calculators are fine. We can now answer the question because we now know the cost of the fajita and the cost of the taco, which is what we were looking for. So we need to answer the question. So fajitas cost $2.50 and tacos cost $1.50. And you put the dollar sign there because it is cost. So fajitas cost $2.50 and tacos cost $1.50. Okay. And like I said, I want to go through a couple of more word problem examples. I think maybe we'll just do one and then do one more tomorrow. And then we want to talk about the scenario that we saw up here. How do you tell when there is no solution, for example? Okay, so if you guys go to our notes, we don't have that much left in the notes. We have a couple more word problems on page 6. And like I said, I think we'll just do one today. We'll do the last one here tomorrow, just so that we have something for tomorrow. And then we're going to fill in this page here, which is how can you determine the number of solutions? And that's it. If you look at your notes, if you were to print them out or look at them online, you'll notice that there's this extraneous page at the end. Extraneous means extra, not needed. It was a mistake. We're not doing anything with polygons in this chapter, so you can just X out that page or just not print it out or throw it away. I don't care, but you do not need to turn anything in on this page dealing with polygons and triangles and stuff, because we are doing systems. We are not doing any geometry right this moment. Okay, so on page 6, there's another word problem, okay? And again, I mean, we know how to do this. We've gone over it, but I just want to give you guys as many examples as we can on the word problems. It does not mean that when you guys take your test on Thursday and Friday, so group A that's in class right now, you guys will be doing your ESA on Thursday. Group B, you'll be doing it on Friday. We're going to be doing them in class. You can expect there to be word problems, but not like the entire test is word problems. There'll be, you know, for sure 1, maybe 2. So we're not talking about that your entire test is going to be word problems, but you know, we want to make sure that you've seen enough examples with how to set up the systems for a word problem and how to solve it. The test this week on Thursday and Friday will go into the semester grade because your semester ends next Friday. October 9th, next Friday, 1 week from this Friday, is the end of the semester. And if you are passing all of your essential skills, we have 3 of them. We had functions, we had linear relationships, and now we're going to have systems. This is our 3rd one. If you pass all 3 of those essential skills and your overall grade is 70% or higher, you will have a grade on your report card, which goes on your transcripts, which earns you 5 credits of math. Okay? To graduate, you need 30 credits of math. So you don't graduate just by, you know, being here. You graduate by earning the appropriate number of credits in each subject. And math, you need 30 credits before you graduate. So you guys are going to all earn next week, if you're passing, your first 5 credits of math. And, you know, whatever other classes you're taking. You earn 5 credits for every class you take. But there are other requirements, like you need 40 credits of language arts. You need, I don't remember how many, but you need some credits of like performing arts, like music and things like that. There's so many credits you need in a foreign language. There's so many credits of PE that you need. So I do know for sure that it's 30 credits of math, because that's, you know, kind of my thing here is the math. Okay, movie theater. Surprisingly, only sold 133 tickets to a movie documenting how awesome Mr. Anderson, Ms. Armstrong, Mr. Suffens, Ms. Stadler, Ms. Riar, Ms. Pena, and Ms. Lovett are. These are all math teachers here on campus, by the way, so this is an awesome documentary. Even though, amazingly, they didn't sell out the theater, they sold 133 tickets, they still managed to collect $1,274 from ticket sales. The student ticket sold for $8. The adult ticket sold for $11. Then the question is, how many of each type of ticket were sold for this one-of-a-kind performance? So we need to know how many of each type of ticket were sold. And the 2 types are student tickets and adult tickets. So we need to set up 2 variables to represent how many of each type. So we have student tickets, we have adult tickets, so we could do S equals the number of student tickets sold and then logically, I would choose A to be the number of adult tickets sold. Be careful with S's, because S's sometimes look like 5s. So sometimes when I write an S, I put like little marks on the end so that for me, I can distinguish them between my number 5s. Same thing, you'll see math teachers, you know, they do Z's a lot with a cross in them. That's so that they don't look like the number 2, because Z's and 2's can look a lot alike and you don't want to get them confused when you're solving a problem. So S is the number of student tickets sold. A is the number of adult tickets that are sold. And the first thing we know is they sold 133 tickets. And there's only 2 types of tickets, student tickets and adult tickets. And total, they sold 133 tickets. So my first equation is literally going to say the number of student tickets plus the number of adult tickets is a total of 133 tickets sold. So my student tickets plus my adult tickets totals to 133. Now the other information in here is about the money. So it's how much money they collected. They collected a total of $12.74. That $12.74 was calculated by student tickets for $8 each and adult tickets for $11 each. So we can calculate and set up an equation for the total amount of money that was collected by knowing that $8 for every student ticket, plus they also collected $11 for every adult ticket for a total of $12.74. I'm going to make that 74 look better. So 12.74, that looks better. Sometimes I cross my 7s like they do in Europe, and sometimes I don't. But that is an S, not a 5. Okay, so here's my system. Total of 133 tickets between students and adults. Total of $1,274, and that is calculated by $8 per student ticket plus $11 per adult ticket for a total of $1,274. Okay, now we need to solve. S's are lined up, A's are lined up, equal signs are lined up. I'm going to do elimination. So I think we can eliminate by multiplying this first equation by something. So what do you guys want to do? Eliminate the S's or the A's? Okay, A's. This is 11. I need to make that one negative 11. So let's multiply by negative 11. So I now have negative 11S minus 11A equals, and this would be a good place for a calculator because 133 times 11 is just not off the top of my head, but that is negative 1463. Okay, second equation I don't need to do anything with, so 8S plus 11A equals 1274. And I fortunately noticed there's no 5s in this problem, so I shouldn't get my S's mixed up with my 5s since there's literally no 5s. Okay, adding right here. Negative 3S. And my A's eliminate. Equals. I got to do negative 1463 and add 1274. That gives me negative 189. Now, S is the number of student tickets sold. So I know that my answer needs to be positive and it needs to be a whole number. Okay, they're not going to sell like 2.3 tickets. You have to sell tickets in whole numbers. So a negative divided by a negative is going to give me a positive, so that's good. And then I need to do 189 divided by 3 and make sure that it goes in evenly, and it does. It gives me 63. So I now know that they sold 63 student tickets. And remember this equation, this is my easier equation. They sold a total of 133 tickets. If 63 of them were student tickets, that leaves 70 to be adult tickets, because these two have to add up to 133. So I actually know the answer here. So they sold 63 student tickets. And 70 adult tickets. Okay. Like I said, I'll do the next word problem tomorrow, just to leave something for tomorrow. Okay. I figure at least doing a word problem a day this week will help you guys out. Okay, the last page of notes here on page 7 is really what our essential question is today, which is how can I determine the number of solutions that we will get when we solve a system? And we kind of already looked at this a little bit with the warm-up where we did have a no solution problem, but there are 3 different scenarios when you solve a system. A system is 2 lines, okay? Most of the time, this is what happens. You have 2 lines, they intersect, that's your solution. Your solution is x comma y. So most of the times when I give you a system, you will have a system that intersects at one point, and that's your solution. But it is possible that you have parallel lines. Parallel lines do not intersect. There's no points in common. The solution, that circle with a line through it, stands for the empty set, which is just a fancy way of saying no solution. So most of you guys will probably just write no solution. But there is a 3rd scenario as well. And we looked at this once last week where you could graph 2 lines. And notice it doesn't even look like there's 2 lines. That's because the second line is right on top of the first line. You can't even tell that there's 2 lines here. So these are called coincident lines or coincidental lines. Just means that they lie right on top of each other. And they intersect everywhere along the line. So there are infinitely many solutions. So notice it says infinitely many points in common. And the solutions are basically every point x, y that's on that line. So if I asked you, where are the solutions? It's every point on this line. If I asked you, how many solutions? Infinitely many. How many solutions? 1. How many solutions? None. These are the only 3 things that can happen when you solve a system. Now, if you're looking at a graph, it's easy to tell. I mean, you can tell that these are parallel. You can even really tell if they're parallel if you make sure they have the same slope. That's what would make them parallel. You can tell by looking at a graph that they're going to intersect once. Here you can tell if you can't even see the second line, then you know, oh yeah, they're coincident lines. There are infinitely many solutions. But what happens if you're solving algebraically? In other words, what happens if you're not graphing them? How can you tell? Okay, so that's what we're going to look at here. So majority of the time, a system of linear equations will intersect at one point, and there will be one solution. And we know that our one solution is written like that. That's our one solution. However, you could have a set of parallel lines. They never intersect, so they have no solution. Okay? You can recognize them on a graph because they have equal slope. If they're in slope intercept form, the equations, you might notice, oh, they have the same slope. They're parallel, so you could maybe recognize them that way. But what's going to happen is when you try to solve it, all the variables will eliminate, and you will be left with 2 numbers on either side of the equal sign. And the 2 numbers will not equal each other. This is what happened on the warm-up. We had a 0 on one side and we had a 31 on the other side. When the two numbers that are left after the variables disappear, if they're not equal, then that tells you that there are parallel lines. There's no solution. So when this happens, you say no solution because the lines are parallel. However, if you solve, the variables eliminate. It could be that you have coincidental lines, meaning that they're really the same line, and there's infinitely many solutions. What happens when you solve it algebraically? You will have two numbers left, and they will be the same number. These two numbers are equal to each other. So when something like that happens, it doesn't have to be threes, it can be any number, but when that happens, you are going to say infinitely many solutions. Okay, don't say all solutions because it's not all solutions. It's just the solutions on the line, but there are infinitely many. So on your Delta Math tonight, it's going to ask you to look at a system and it's multiple choice. It'll say choices, no solution, infinitely many solutions, or one solution. So it's a multiple choice, basically, and you'll be choosing how many solutions there are. So yeah, you kind of want to do the problem on paper and figure out which scenario it is. Is there one solution, no solutions, or infinitely many? So we're going to do two examples right here. Okay, we know one solution is when you get a solution. Here, I see y equals negative 2x plus 3. So I'm going to do substitution, and I'm going to take that negative 2x plus 3 and put it right here where the y is. So substitution. So equation number 1 is going to become 4x plus 2y equals 5. But instead of the y right there, we're going to put in negative 2x plus 3. And we're going to distribute. 4x minus 4x, 2 times 3 is 6, equals 5. We are attempting to solve for x here. However, look at what happens. 4x minus 4x, my x's have essentially eliminated. I get 0 when I combine the x's. On the left side of the equation, I have a 6. On the right side of the equation, I have a 5. Are those two numbers equal? So 6 equal to 5? Nope, they are not equal. So that means there is no solution. 6 will never equal 5, no matter what you try to do here. You can never make 6 equal to 5. There is no solution, okay? And if you wanted to say, why is there no solution? It's because these lines are parallel. So that's just a reminder. That's what it really means. No solution means we have parallel lines, okay? So if you were to graph these two lines, they would end up with the same slope and they would be parallel to each other. Okay, so second and last example here. There's y equals, there's a y. So I can take this and put it where that y is. So equation number 1 now becomes 3x minus 6, y equals 12. But instead of y, I'm going to put in 1/2 x minus 2. And I know that's a fraction, but when we multiply it, the fraction will go away, which is kind of nice here. And if it helps you, you can put a 1 under the 6. Okay, so 3x, distribute right here, I get negative 6 divided by 2. So negative 6 times 1 is negative 6, and then 1 times 2 down here is 2. So this is going to give me negative 3x. Because this is negative, that's positive, so I get a negative. And then negative times a negative is a positive 12. And same thing, 3x minus 3x, that eliminates. The x's are gone. So on the left, I have a 12. On the right, I have a 12. So it's important that you go all the way because you got to know at the end whether these numbers are equal to each other. Is 12 equal to 12? Yep. So that means there are infinitely many solutions. These two are the same line. This equation is the same equation as that. It's just written in a different form. If you took this top equation and changed it into slope-intercept form, you would get the exact same equation. These are the same line. So there are infinitely many solutions. And if you ask, well, how can that happen? It happens when your two lines are the same line. Okay, so when you solve a system and both lines are literally the same line, you will get infinitely many solutions. Okay, so every point on the line here is also on that line because they're the same. So those are all the solutions. All the points on the line are the solutions. Okay, so let's see what we're at. We're at 10 or 9:48. So you guys have some time to go on to Delta Math. Like I said, the new assignment for tonight has you doing this and multiple choice deciding how many solutions there are. Your options will be infinitely many solutions, no solution, or what usually happens, one solution. So you will need to look at each of the set of lines, the system, and decide how many solutions there are, okay? And you probably cannot tell just by looking, okay? When two lines are the same line, they usually will write the two equations so that they don't necessarily look the same. So you might not be able to tell by looking that these two were the same line, but you can tell when you try to solve. When all the variables go away, look at what's left. If the numbers are equal, it's infinitely many solutions. If the numbers that are left are not equal, then there's no solution. And remember that one of these numbers, if you're doing elimination, is going to be a 0. Like we did on the warm-up today. We did elimination right here. Don't forget to write the 0. Eliminate, eliminate. There's 0. So when you eliminate, you get 0. So there still needs to be two numbers here. And you need to ultimately decide if the numbers that are left are equal or not equal. And of course, if your x's and y's do not eliminate completely, you will get one solution like this, okay? So here I did not eliminate my x's. I substituted, so there's no y's, but the x's do not go away. That's why we get one solution, okay? So the Delta Math has you do that. And there's a second section on Delta Math that just has you do a combination of all the different types of systems. So there's two skill sets. One, how many solutions are there? Second skill set is just a mixture of systems, all different types, to get you ready for the ESA Thursday and Friday. Also on Schoology, if you look, I posted review sheets for the next 2 days. So there are review sheets. One of them will be due tomorrow. Another one will be due on Wednesday because the ESA is on Thursday. Also, your notes are due Wednesday. So you've got, you know, all of the work for the week is posted already. If you're behind on any Delta Math, you can still do all of those between now and Wednesday, plus tonight's Delta Math, plus the two review sheets that are online. Okay, so you guys have plenty of things to practice that are available to you through Delta Math and Schoology. And you want to make sure that you are ready for the ESA on Thursday or Friday, depending on which day you're taking it. If you need extra help, I am here during office hours. Not today, because we don't have office hours on Mondays, but I am here tomorrow and Wednesday. So please let me know that you want an appointment, and I will meet you during office hours, and we can go through any additional practice problems that you guys want. Okay? So those of you guys online, that's it. We're done. You can log off and just work on your stuff, or you can stay on if you want. That's up to you.